Ready. So we have been learning about how information is transferred from place to place. This is lesson 3 from unit 3 in your Dimensions book. And we're nearly finished. I think we've got 2 more lessons. Not sure. Yesterday, we had a look at sound waves, which you guys are like experts on at this point, radio waves, or how those sound waves get converted into radio waves. First, they get transformed into code. Cell phones work, how we've been communicating with cell phones. So I'm here to look at the cord phone as well, the one that's got a wire attached to it, because obviously that doesn't send through radio waves, that sends through electrical signals. But you know that. I'm going to ask you to see how well you know that shortly. So I guess that means that today we're going to have a look at pixels after we've reviewed those sound waves and radio waves and cell phones with our Mr. and Mrs. Elephant. And soon, very soon, we will understand what the connection is with elephants. That's tomorrow's lesson, I think. So here we have Mr. Elephant on his phone, and there's something coming out of it. And I wonder what is coming out of Mr. Elephant's phone. Once the cell phone has converted the sound waves into code and converted the code into radio waves, it sends them somewhere to kind of ping them across the world or distance or over great distances. Where does the cell phone send the radio wave? What does it send it to?
It sends it to the cell phone tower.
Good job, that's right. After it's converted it into radio waves, we send it to a cell phone tower or a radio tower. And then it sends that signal from tower to satellite to tower to get it where it needs to go. After we've learned about pixels and cell phones and radio waves, we'll have a look at elephants. So I've got a nice pixelated image of an elephant down there, but more on that tomorrow. So this is what we had a look at yesterday. I wonder if Dorito, can you tell me about an information transfer that happens inside the phone?
From sound waves to code.
That's right. Anna, when you turn your microphone on, just let me know. What about Ling?
The cell phone tower.
Good job. That's right. So after it's converted it into radio waves, we send it to a cell phone tower or a radio tower. And then it sends that signal from tower to satellite to tower to get it where it needs to go. After we've learned about pixels and cell phones and radio waves, have a look at elephants. So I've got a nice pixelated image of an elephant down there, but more on that tomorrow. So this is what we had a look at yesterday. I wonder if Dorito, can you tell me about an information transfer that happens inside the phone?
From sound waves to code.
And then code to?
And code to radio waves.
Good job. If it changes, it's also transformation. Okay, it's also changing the energy from sound waves into radio waves. What's one way that information is transferred outside the phone?
Cell phone tower?
Yeah, radio waves get sent to cell phone towers. Good. And then what happens once it reaches the first tower? What happens to the radio waves after that? They get sent from?
Tower.
Exactly. Good job. Thank you, Ling. Inside the phone, the sound waves are converted into code and from code into radio waves. And then outside of the phone, that information is transferred to the cell phone towers, to tower, to tower, to tower, to satellite, to tower, until it reaches Mrs. Elephant's phone. Once it reaches Mrs. Elephant's phone, Zhang, can you tell me about an information transfer that happens inside Mrs. Elephant's phone? Now she's received it as radio waves.
The code.
Yeah, it gets changed into code, and then from code into what? What kind of yeah, good job. I was going to say, what kind of energy does she hear? Exactly. Cool. Thank you, Zhang. I wonder if anybody can tell me, why do we use radio waves? It's related to the amount of energy it uses, and it's related to the distance it can travel.
Because they need less energy.
Ben, what about the distance that radio waves can travel?
Very far.
Why? It's not to do with the energy, it's to do with the wave
length.
Has a radio wave got a long wavelength or a short wavelength?
Long wavelength.
Thank you. So cord phones don't send information via radio waves because they've got a cord. And if it's got a cord, what kind of energy does it use, Layla?
Electrical signals.
Exactly. Good job. Sound waves get converted into electrical signals. And then where do those electrical signals go?
Transfers through wires.
Good job. That's right. Yeah, it transfers through wires. Much like the internet hubs that we learned about. So with the internet, we saw that underground copper wires were used to transfer electrical signals. If we wanted to send it under the ocean, under great distances, we used fiber optic cables, which use light energy. Jenny, so our sound waves have been converted into electrical signals. Those signals have been sent through the wire. And once those electrical signals get to the receiving phone, what happens?
It's changed from electrical signals to sound waves.
Exactly, that's right. Yeah, thank you very much. Okay, so that's all you really need to know about cord phones, is that there's different ways, depending on the kind of phone, depending on the type of device that you're using, information is able to be sent through different ways. Now, I'm going to ask you guys to turn your microphones on, and I want you to read this out, including blah, blah, blahs for the blank spaces. So first time we're going to read it, just blah, blah, blahs for the empty spaces. Then I'm going to ask you which word goes where, and I need to give you a hint because actually tower gets used twice. That's a big hint, really.
Convert blah blah blah
Into
blah 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 and then send blah blah
cell phones convert sound waves or light waves or the radio waves or microwaves or tower or trough.
Sound waves.
Sound waves, good. So, into what, guys?
into
Radio wave.
Yes. Then what happens?
tower.
From here, they relate to other towers.
From here, eventually arrive at other tower. At a near pole.
Good job. Okay.
Near
Everybody, I want you to read this again with the correct words in it.
cell phones convert to radio
Eventually arrive
Good job. So, cell phones convert sound waves into radio waves. We know this. We've done this for like 2 days now. They are sent to a cell tower. From here, they relay to another tower. They eventually arrive at a tower near another phone. And then, what isn't said there is then they convert the radio waves back into sound waves. We finished with the cell phones for now. Yes, okay. So unfortunately, we're not talking about Super Mario. We're not talking about Minecraft. And we're not talking about Among Us. However, all related to the next mini topic that we're doing. And I figured these images would, according to your reactions, these little images would get your attention. So what's the next part in our lesson? Amy?
Pixels.
Pixels. Yeah, it's time for pixels. Pixels. Thank you, Amy. Who's going to tell me what pixels are, what they look like, or where we see pixels? Somebody tell me anything about pixels at all. What do you know about pixels, or where do we see pixels?
on the computers or
Yeah,
iPad.
good job. And these pixels, what shape are they?
Just blocks.
Yeah, they're boxes. Mon, this is a tough one. Can you remember how we make pixels? What kind of code do we use to make pixels?
These are in on.
Yeah, okay. So it's the 0s and 1 code. That's all right. Thank you, Mon. I'll ask somebody else. What's the 0s and 1 code that we use to make pixels?
Binary code.
Good job. Exactly. So yeah, we use binary code. It's made up of 0s and 1s, or bits and bytes, builds pixels in our computer. And then those pixels in turn build up an image. Bits of color. So once again, I'm going to ask you guys to read this all together. It's the last little bit of reading, I promise. Would you kindly refrain from shouting? Turn your microphones on, please, to read this out. Okay, so bits of color.
pixels are clearer and brighter, making the more the TVs has more resolution than today. The number of pixels on its today's TV got more brighter and more high definition that you might have heard called
HD, good. Down here, we've got two pictures of an apple. One of them's got a little bit more detail than the other, but they're both made up of pixels, and they're both made up of the same colored pixels. What I want you to do in a moment is I'm going to turn on annotation, and I want you to circle the apple with low resolution. I want you to circle the apple that doesn't have very many pixels, okay? Good job. Yep, that'll do. Stop. Bill, why did you choose that apple?
Because it has less pixels than the other apple.
How do you know? What does it look like?
It looks not like a real apple.
Yeah, it looks quite blocky. Yeah. Thank you. And then super quickly, put a circle around the high definition apple. Okay, we should know which one that is. Good job, Hang Me. We should know which one that is because we'll have more detail. The edges will be smoother. Okay, and stop. You guys are correct. Just a quick little bit on pixels. I've got some homework for you. In a sense, it's not really homework. What I want you to do is, now I've been informed that you can't play this game on a tablet, but you can play it on a computer. What I want you to do is have a look at this game, this platform game. And tomorrow I want you to tell me if it's high resolution or low resolution, and if it's got lots of pixels or fewer pixels than normal, okay?